Right, thank you, admin. So let's get started. So today's topic, can anybody see the slide here? Okay, hopefully you can hear, you can see, sorry. So today's topic is the IPsec, IP security. So it's a technology that provides security on layer 3, okay. The agenda will be introduction and then review, securities, and the IPsec itself, and then IPsec on Mikrotik. So I think this is important because when you configure IPsec, at least you need to understand the concept of the IPsec itself. Otherwise, uh, yeah, you will get lost with the configuration because there are lots of them. Okay, so first we talk about the basic knowledge that we assume you already have, and then about the security, and then the IPsec. Okay, about the GLC, we are Garda Lintas Cakrawala. We are based in Bandung. We are doing a training in IT consulting. We are partner for Mikrotik, Ubiquity, and Linux Foundations. We also have a GLC Radius Manager. We also do a regular event like what we are doing now. About myself, my name is Achmad Mardiansyah. I'm based in Bandung. I'm a trainer doing training for Linux, Ubiquity, Cisco, Mikrotik, of course, and other stuff. So I'm also teaching in the university. Also, if you have LinkedIn, we can connect to it. The past experience, we do integration, network integrations. We like convert a network from a bridge network to routed network. Okay. Also do integrations like IoT and radius or billing integration. About the webinar itself, we start doing it since the time is then. Sorry for that. A full screen. Oh, okay. I'm not sure how to do it. Okay, let me share. Okay, let me change the slide. Hopefully this one better. Yeah. Okay. Yeah, so GLC webinar is it's an event started from 2010s, and then we would like to do it every week on Thursday evening. And then from yourself, I can see some of you already introduced yourself. Some are from Indonesian, of course, yes. And oh, I can see here one from Sofia, Bulgaria. Okay. Dobar dan. And then from Philippines, yes. Thank you very much for coming. Right. Others are from, I'm not sure here. Usually there are some persons from Australia and from Taiwan. Yeah, I mean, but anyway, you can just introduce yourself here, right? So everyone can know where you're from. Okay, so let's continue. This is not for beginner. So we assume you already have an understanding about the encapsulation process, routing, security concept, encryption, and then some basics of Mikrotik. Okay, so review. So first is, as we know, we assume you already know the 7 OC layer protocols. Okay, so here we have 7 OC layers. Okay, so layer 1, layer 2, layer 3, layer 4, 5, 6, and 7. So basically, when we do communications, we split the communication into layers, and then inside the layers, we have a particular protocol for communication, okay? Like TCP here is on TCP or UDP. On layer 4, we have IP, and then we have on layer 2, we have Ethernet, frame relay, Wi-Fi, Ethernet, and then so on and so forth, okay? So just for review. And then we have, because we have a layered communications, and then each layer responsible for one function. And then during the communication, we will do the encapsulation, right? So when you send a package, so the data will be sent from the upper layer to the lower layer. So this is your data, and then your data will be added by header, and then another header, and then another header. So before they send on layer 2 here, also they add a trailer, okay? And then every layer, we have a name for every encapsulation results, okay? For example, in layer 4, we have a segment and datagram. In layer 3, if you finish the layer 3, the result is called the packets, and on layer 2, it's called the frame, right? So, and then as you can see, this is how the encapsulation looks like. Okay, so one square here. So this is one square, okay, equals to 1 byte, and then equals to 1 bits. So if you say hello on your WhatsApp, sorry, actually the computer is not only sending hello itself, but it will be added based on the layers it is processing. So you're sending hello on layer 4, you will add TCP, and on layer 3, this process will add more header. So as you can see, actually what you are typing is not same with the one that you are sending, okay? So if you are using Ethernet, okay, with the LAN cable, so this is the total length of your data. If you are using Wi-Fi, and then you will see this long, okay? So that's the encapsulation process. So why do we need that? Because of the communication design. Also, we also learn about the routing tables. Okay, so we have routers, and then the router communicate to one and others. And then in order to forward packets, so there is a packet coming in, and then needs to be forwarded by this router, okay? This router R1 will forward a packet to other destination based on the routing table here. So basically the routing table consists of 2 columns, okay? The destination and then the gateway. Okay, so that's how we do the routing. All right. And about the aspect of security. So when we talk about security, usually the general term that we use is CIA. First is confidentiality. So we want to make sure that the data is confidential. Only a person who is able to see the data is able to do that. Okay, so not everyone can see. So it's confidential. And then make sure that the data has integrity. So it means that when you send data from A to B, okay, with integrity, data, for example, is, for example, 30 bytes, and then it sends also 30 bytes with the same amount of characters. Okay, so no character is changed. Okay, so if you send, for example, 300 USD, okay, and then here they change it to 100 USD. So the total character is the same, but the meaning is different. Okay, so we want to have a integrity to make sure that no information change. Okay, and then we have availability. Make sure that the server or services is always be accessible all the time. Also, other model, security model is AAA, usually implemented in Radius implementation, Radius software. Okay, so you have AAA. Okay, first A is authentication. Make sure it's registered user, only registered user can access. So, for example, the technology are using what you know, using username and password, like what you have, like token and SMS, and then what you are, like retina scan or fingerprint. Okay, so those are the security for authentication. And then after it, authentication means it's a technology to make sure that you are the right person who is able to access the network. Next is the authorization. Okay, so after you authenticate, you already log into the network, and then what kind of rights you get? Yeah, so here you can use access control. So for example, you can access YouTube, but you cannot access the other websites. So these are the list of websites. So that kind of authorization policy. Okay, and then, for example, other authorization is restrictions. For example, you're allowed for maximum 1 Mbps speed, for example. That's kind of authorization. So after you log in is authentication, and then your rights is the authorizations. Next is accounting. And then it's accounting what you are doing during the activities like traffic volume, online, and others. Okay, so that was the AAA models. So, oh, okay. So this one is a little bit small. Yeah. So as you can see, we already have a 7 OC layer, right? We have layer 7 until layer 1. Okay. And in every layer, we have protocols. Okay. And then here, it's from Javin. Okay. You can actually this is yeah, you can check their own website to get this kind of map. Okay. So because in every layer it has its own security issue. Okay. So for example, this is top threats, vulnerabilities, malware, IDS, IPS, AAA, firewall, VPN. Okay. And then these are the top threats that happening on every layers. And then here you can see the layer defense on every layer. So for example, in order to provide security, okay, on layer 7, these are the technologies, okay. And then here's a layer 6, layer 5, layer 4, and 3. So where is IPsec? IPsec is part of VPN here. Okay, so in order to make sure that our communication is secure. Right. Guys, if you have any questions, and then I mean, please feel free to answer the. I mean, not to answer. I mean, just type something on the chat box. Okay. Sorry. So here's the more details about the concept. Okay. So this is the service. Okay, like confidentiality, access control, authentication, right? Integrity, non-repudiation means you cannot deny. And then here's the availability. Some mechanism, you can do it with encryptions, digital signature, and then access control, data integrity, and then others. Okay, so this is the service, and then here's the mechanism. Is the technical implementation of how you achieve the service. Okay, so here. Okay, so next is cryptography. So cryptography means it's a study or practice techniques in the presence, the way you secure communications. Okay, so we want to secure from A to B. Okay, and then we are aware there's a presence of third parties. Okay, so somebody is doing something here, you are aware that there are third party that is sniffing your data, right? So that's the encryption. So we are doing encryptions, and then there are two types of encryption. We have symmetric encryption with the shared key, same key for encryption and then decryption. Okay, so same key. And then we have asymmetric encryptions. So here, the key for encryptions is similar. I mean, it's not similar to decryption here. So you send this data, okay, over the network, and then here's the result. So when B receives the data, okay, B will use the private key. Okay. I have one question here. Does the concept of GRE tunneling same as IPsec? No, it's not. So GRE is general routing encapsulation. Here is different. Yeah. Now let's talk about IPsec. Okay, so those are the fundamental things that you need to understand. So let's talk about IPsec. Okay, so hopefully that was answer your questions. Mr. Amir Daniel, yeah. Okay, another question, send the PDF on the chat. I'm not sure what you're talking about. I don't see any chat PDF here. Sorry. So first, here we talk about the IPsec. Okay. So why we use IPsec? Because we have issues on layer 3. What is layer 3? Is for IP layers, right? We have either IPv4 or IPv6. Okay, so only two options we are using on. I mean, as the facto implementation in the world of layer 3, we have two types. Sorry, pardon. We have V4 and V6. Okay, so we define security as in the previous slides like this. Okay, okay. Encryption, and then authentication, confidentiality, integration, okay, integrity. But the originally IP is not designed like that. Okay, so there is no security features. AAA, okay, no AAA, but no AAA. Sorry. So IP is designed in early stage where security is not an issue. So we assume all hosts are trusted, right? Like a BGP. I want to do BGP with you because I trust you. Okay, so trust is BGP. Okay, because I want to peer with you because internet is based on trust. Okay, if I don't trust you and then I don't want to connect with you. Okay, or hosts are known. Okay, in the beginning. So when we design IP protocol, we think, oh, okay, yeah, I know you, you know me, and then no problem lah. Yeah. So with this design, we have security issues like source spoofing, replay packets, and then here data integrity or confidentiality. Okay, so if somebody's sniffing on your data, they can see it clearly, right? So yeah. So that's the issue on layer 3. So it comes with the IPsec. So it's a set of protocols, okay, an algorithm to secure IP data on the network layer. So it's a security extension on layer 3, especially on IPv6. So IPv6, so when you see IPv6 header, so there is a next, so this is the header, right? So header, 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 and then here's the payload. Okay, so on the header of IPv6, there is a next header that is clearly state that, okay, the next header is for IPsec. Okay, so that's IPsec. And then because we do the security on layer 3, we can provide a blanket security for applications. So it's like a transparent for application. So the application do not need to be aware of IPsec. So we don't have to rewrite program to make it secure. Okay. For example, telnet, right? How to secure telnet. So telnet is not secure, but how can you make it secure? By using IPsec, for example. Yeah, so this one, because there are many applications. Maybe now it's reduced because there are many applications out there. Because the developer do not want to change their code. They want to do it as it is. So maybe one way we can implement IPsec so that we can communicate with the application securely. Okay. So for example, you have HTTP, right? Okay. This is no encryption. Okay. And then the implementation, so the software programmers needs to rewrite the code so that HTTP can support a secure. Okay, so we have to rewrite the program in order to provide security. Okay, so what if the applications developer do not have resources to make the application secure, for example, because of the library, because of the many restriction. Okay, so IPsec can be the answer. So IPsec components can be security association or policy, security authentication headers, ESP, or IKE. Okay, yeah. Usually IPsec is implemented with as a VPN technology, either router to router or end device to router. So, for example, yes. So yeah, here. So this is router one. Oops. So IPsec can be defined like so from here and here. So this is the IP address, right? And then here's the interface. Okay, interface has their own IP. So side to side will be like this. Okay, so we are connecting here with IPsec. Okay. Okay, so IPsec between router 1 and router 3. So that's first implementation. Second implementation can be from end device, so end device, to the IPsec or the VPN server. Okay, so this is the end device. Okay, client, and then this is the server. Okay, so this is the also IPsec. Okay. Yeah, that's the implementation of IPsec. We'll be talking about this in the tunnel mode and uh, yeah, header mode. Okay, so hopefully you can, yeah, you can understand that. Yeah, so router to router, okay, or end device to routers, like a root warrior from your laptop, from end device, okay. From router to router, it's like side-to-side VPN, like Mikrotik to Mikrotik, and then from FortiGate to FortiGate, from whatever, Sophos to Sophos, yeah. So, yeah, that's the example of the implementation of IPsec. The IPsec can provide what? First is integrity, okay, or confidentiality, okay. So confidentiality means when you see the package, I mean, the data is encrypted, okay. So yeah, IPsec can encrypt. Integrity, so they are using hash algorithm. So if you change something, and then the hash will be different, and then we know that, oh, okay, package is, I mean, the data is changed during the transfer from A to B. Okay, and then authentication to make sure that, okay, you are the one who is login, okay, to make sure that, okay, you are a legitimate user, okay, or legitimate IP address. And then anti-replay protection, so it means that the data cannot be replied. Okay, and then key management here. So previously when we do encapsulations, we have a public key and private key, right? So with the key management on IPsec, we can do it smoothly. The good thing for IPsec is IPsec still allow normal router to forward IPsec packets. So we don't have to be, so the router, so we have A, this is end device A, and then we have another router here. This is B. We have another router here. Okay. So actually we want to connect from A to B, okay, along the path here. So all router here do not have to aware of IPsec. Okay, so router is just a normal router. They just forward the IPsec packets, and then just like nothing happens. Okay, so that's the beauty of IPsec. IPsec, sorry, sorry. So IPsec standard, sorry. Why do I always say like that? IPsec standard, okay. So these are the RFC. 4001, 02, 03. Okay, so these are three main components of IPsec. Okay, actually, if you already read this, and then you don't have to come to this webinar, right? And then we have another, because you can see this is 4001, 02, 03. So they are released in a consecutive order, right? Orderly manner. So it means that they're come in one time, one after another. So it looks like they already designed in that way, okay, in orderly manner. This is about the, okay, so this is the original IPsec architecture. 02 is about the authentication header, and then 03 is about the ESP, encapsulating security payload. And then we have IPsec camp. We call it IPsec camp for security management, key management. And then because this is IKE1, okay, IKE1. And then people are complaining this IKE1. Why? Because it has problem with compatibility, yeah. Especially if you do IPsec between vendor, right? Okay, so please tell me about that, right? So from vendor A to vendor B, okay, we do IPsec and then not successful. It has to be Cisco and Cisco, FortiGate and FortiGate, Mikrotik and Mikrotik. So that's the problem with IKE1. People complain, and then there we have IKE version 2. This one is much better. Mikrotik also support IKE version 2. And then the last one is, I think IKE version 2 will be discussed in the next webinar. Yeah. Yeah, others, RFC 4835, it's algorithm implementation on ESP and AH. Okay, so yeah, so that's the standards of IPsec. So actually, if you read this, and then you don't have to come to this webinar. Okay, about the mode, the IPsec mode actually includes tunnel mode and transport mode. Okay, so tunnel mode means packet is encrypted, so it's like side-to-side VPN. So it's like IP on top of IP. Okay, so we have, you will have a 2-layer 3. Okay, so we have layer 3 here, and then we have another layer 3. So it looks like VPNs, like PPTP or whatever. Okay, so you have a first layer, okay, first IP address, and then on top of that, there will be another layer 3. Yeah, that's internal mode. So that one is used especially for a site-to-site VPN. Okay. Next is transport mode. So here IPsec insert into IP packets. So there is no new package created. Okay. Yeah, it works well. Yeah, if the increasing packet size could cause an issue. Yeah. So yeah, so this will become a payload. Okay. Frequently used for remote access VPN. So this is for road warrior. So from end device to the router. So this one is good between router to router. Okay, because they will do they will encapsulate an IP inside an IP. I will show you the encapsulation process later on. Okay. The architecture. So we have a security policy here. Okay. Yeah, or IPsec policy. Yeah, in a Mikrotik word. Yeah, and then either we can use authentication header or ESP or IKE. So it's up to us. Okay. So we can choose implementation of IPsec. Okay. Either you can use just authentication header only, or ESP, or IKE. Okay. Okay. Right. So this is security protocols. Okay. Either authentication header or ESP. Right. Yeah. Okay. So these are the two main things of IPsec, AH and ESP. Okay. And then for key exchange, you can use IKE. Okay, so two main technologies of IPsec are AH and ESP. Okay, so security association is a collection of parameters to establish secure sessions. In here, you are using SPI. Okay, secure parameter index, IP destination address, and then security protocol identifier. So that can be uni or bidirectional, and then single can be used for single SA, security association, can be used for AH or ESP, but not both. Okay. How it looks like? Well, it looks like, oh yeah, before we talk about the we talk about the ISACAMP. So ISACAMP is the protocol for key management protocol, because previously we know that the encryption requires symmetric and then asymmetric key, right? So that's why we need to have a technology to manage the key defined here on this RFC, and then used for establishing security association, for establish cryptographic key, and then after that we can establish uh, uh, the data transfer. Okay, so as I said previously, we have two options, either AH or ESP. Okay, and then this is the authentication header if we use. So hopefully you can see here. Okay, so this is to provide authentication and data integrity. So this is the data that you are sending, right? Hey, hello, you are sending hello. And then if no IPsec, this is how it looks like. Okay, no IPsec. Okay, and then if we use AH transport mode, this is how it looks like. Okay, so IPsec header will be added here. Okay, so that the router will check the layer 3 information here for doing routing. Okay, so no problem with the traditional routing. So authentication header will be added here. Okay, you can see a block here, a block of cyan color. Okay, so these are the um, fields of IPsec header if you are using authentication header method. Okay, it's using on top of IP. So this is IP, and then here's the AH header. So it will check the IP address here. Okay, to make sure that the data is authentication. So data is authenticated here. So nothing is changed. So it's using hash algorithm. So to make sure that the data is not changed, data is authenticated. Okay, but the issue with AH is no encryption. Okay, so people can see what's happening here. Okay, people can sniff here if you just use the authentication header. And then because, yes, you can see, because we are adding more data, okay, and then perhaps we'll have problem with the MTU. Okay, so MTU is start from here to here. Okay, so that's the MTU. MTU. Okay, so because MTU is 1500, right? 1500 bytes. Okay, so because you add more more data here, perhaps yeah, it could be possible that yeah, the data is larger and then do not fit the MTU, so that you can decrease the MTU size for data transfer. Okay, so again, if you use AH, there will be no encryption, also MTU problem. And then because AH is authenticating the IP address, okay, so you have a source IP address here, you have destination IP address, right? And then in the middle, there are, that can be a change. Okay, for example, NAT. Okay, so if you change something here, okay, and then the hash will be changed. Okay, if the hash change is not similar, and then the destination will reject your IPsec because you're changing. So AH is you need to be careful with the NAT problem, with the NAT issue if you are using AH. Okay, so that was happen in transport mode. If you are using tunnel mode, see, this is tunnel mode. Okay, so what it does is it will encrypt the payload. Okay, so not encrypt, it will authenticate the payload here. And then you will, this is the original IP, okay, original IP address. And then here's the new IP address. Okay, IPsec peer. So it's going to be like this. So you have router 1, okay, and then here's the internet. And then you have router 2, right? And then here you have a server, and then SRV, and then you have a client here, CLT. Okay, connect, 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 and connect. Okay, so the one that is doing the IPsec is between here. So IPsec, this is IPsec, okay? So here they have an IP address, and then here they have an IP address, okay? So packets actually is coming from the client, okay, coming from the clients to the server, okay? When the packets arrive at router 1 from the client here, what it does is it will add a processing like this, okay? So it will encapsulate the original packets. This one here. Yeah, this is the original packets. Add the header, and then add the a new layer 3 header. Okay, so this one here belongs to this because we need to set up a peer of IPsec. Okay, so this IP and then this IP will become an IPsec peer. Okay, so this is tunnel mode. Okay. Okay, so packets arrive at router 1 will be wrapped by IPsec and then sent to the peer here. And then the destination at the router 2, the packet will be decapsulated and then decrypt and then forwarded to the destination. Okay, so that's the fundamental difference between transfer mode and then tunnel mode. Again, if you see AH, there is no encryption here. So it only provides authentication and data integrity. Okay. Any questions so far? No. Is it too difficult or not? Next is ESP. So many people likes this ESP because it has more features compared to the previous one. Okay, I'm sorry for that. Yeah. How can I explain, right? So I try to explain as simple as possible. Yeah, so I'm explaining how the IPsec works, okay? So so again, so when you do IPsec, you have two options, okay? You can choose AH, Authentication Header method, or ESP, Encapsulating Security Payload, okay? Yeah, please try, okay? Just eat it. Just eat it first, okay? And then you can digest it later. Next method is called ESP, encapsulating secure payload. Okay, so as the name suggests, the payload will be encrypted. Okay, it uses protocol 50, everything offered by AH. So it means that integrity, okay, and then what else? Integrity and then authentication, okay, plus confidentiality. It means that there will be an encryption here. Okay, so which is good, right? So that's why, there will be an encryption or decryption process for each packet. Okay, so encryption occur before authentication. So we have to encrypt the data first. Okay, so the data, if there is no IPsec, this is how the data looks like, okay? With IPsec ESP, the data will be like this, okay? So they will put the ESP header in front, and then there will be a ESP trailer here. So what happened with the data between the header and trailer? There will be encrypted here, encrypted data. So they will not see hello. Okay, I think it's applying centralized application. I'm not sure. Okay, so with ESP, here will be encrypted, okay? So everything after ESP header, here will be encrypted. So there will be ESP trailer, and then here, ICV, integrity, whatever. Look, I'm not very good at remembering abbreviations, okay? So this is just a normal layer 3, nothing changed, but it is the IP address is what is it? Is authenticated here. So we do encryption first, and then on ESP header, there will be a a process for make sure the integrity. So there is a hashing a process here to make sure that there is no data, to make sure the data integrity. Okay, so that was in the transfer mode. Okay, if it is in tunnel mode, okay, what you will have, the difference is on here. There will be a new layer for IP. I mean, not yeah, like a encapsulation. So so the original IP here will be the payload. Okay, so from here to here, sorry, yeah, will be encrypted. Okay. Oh, okay, so that means I have to erase that one here. Actually, the one that is encrypted is from here to here. Okay, so this is encrypted, this is encrypted. Okay. Okay, hopefully, lucky I have tried MTCRE. Okay, thank you. Right. So that is the ESP. So that's the difference between AH and ESP. Okay, and then we have a key exchange. Okay, so this is key exchange is used for establishing IPsec session. Okay, so we have a variation of IKE negotiation. We have aggressive versus main mode, and then for the authentication we have a pre-shares. It means that it's the same. Okay, we have a public key encryption or signature. Okay. What's the penalty in this case in terms of traffic latency? I mean, having encryption, it's something that you have to consider deciding with the method you will use. Well, for encryption, Mikrotik has it is recommended if you use router board with hardware acceleration, because encryption requires CPU power. Okay, if you don't want to bog down your CPU processing, and then better if you buy Mikrotik with hardware accelerator, IPsec accelerator. Yeah, and then Mikrotik on their website, Mikrotik has has the data. For example, for IPsec, for RB, I think RB GR RBGR. I'm sure it's the replacement for like RB450, right? GR3, yeah. That can deliver 400 Mbps IPsec. Okay. Without maybe just 100 with no acceleration. So you can refer to their website, the Mikrotik website, what kind of traffic, output traffic you would like to expect. So the interface is 1 giga, 1 Gbps. Okay, so the interface is 1 gigabit per second. But if you want to implement the encrypted traffic, it can go up to 400 Mbps. Okay, that depends on the hardware, yeah. But this is the numbers that I remember. For details, you can check in the Mikrotik website. All right, so hopefully that answers questions. So IKE has a phase here. Okay. So usually we have phase 1 and phase 2. So phase 1 is establishing the secure tunnel, either main mode or aggressive mode. Okay. Checking the computer identity certificate or pre-shared, and then after that, it's established secure channel between computers for transmission data. Okay. And then for the Mikrotik, yeah. Yeah, so this is the general packet flow. It looks scary, but yeah, we can trace that. Yeah, we can start from here. We start from here. This is a physical input interface, okay, inbound interface. It checks whether the interface is breached or not. If not, for example, and then we go here and then checking, is there any, is it MPLS traffic? No, it's not. Okay, go here. Is it IPv4, IPv6 traffic? Yes, okay. And then checking. So here we are entering this box here, which is the routing decision. It means that we are reading the routing tables, yeah, /IP route. Okay, so that one is done in this phase. So by reading the IP routes, we know that, okay, the packet is either input or forward. Okay, if the packet is forward, we go here. Okay, and then check is it the MPLS traffic present, because MPLS is not using IP route, right? MPLS is using the label. MPLS is using label. Remember, label, not routing. Okay, label. So if there is no labels, and then go here. Is it output interface bridge? No, it's not. And then encapsulate? No, and then we go out. So this is one uh, uh, one example of how the encapsulations and then decapsulation happens on Mikrotik. Okay, so this is router. Okay, so you're coming into Ethernet 1. Okay, and then outgoing is Ethernet 2. Okay, so this has happened. So physical interface here is Ethernet 1. Output interface here is Ethernet 2. Okay, so or maybe like this. Okay, right. So that's the general encapsulation flow. For the IPsec, well, it has some modifications. So packets coming, okay, and then goes to pre-routing, and then goes to IP routing decisions, forward, okay, and then we have a forward and then post routing, okay, and then check, okay, is IPsec policy active or not, okay. If it is yes, and then we do encryption. So this is for encryption is for outgoing. Okay, so when a packet, this is a router, packets leave the router. Okay, so we assume that we have a router A, and then this is the internet, and then we have router B. Okay, okay, IPsec. Okay, this is client, and this is the server. Okay, so encryption happens on A. Okay, at outgoing. So this is one way. Okay. So encryption happens here, and then routing decisions, output, okay, and then again another post routing. So two ways. Okay, number 9, number 7, number 8, number 9, number 10. And then the output will be, after number 10, there will be a checking for security policy because we do encryption here. For example, we are adding, we do the tunneling here, right? Tunneling, ESP tunneling. So it means that there will be a new IP address added. So the IP security policy, when they check again, there is no IP security policy, and then the packet leaves the interface. Okay, so this is in, which is in this interface. Okay, and then so when the packet's coming out, and then here it is. Okay, so yeah, so during the decryption, so this is what happened. We have an interface here where we received the IPsec packets. Okay, so this is what happened. So we go pre-routing and then check routing decisions, and then goes for number 3, check input, because the destination, because they are peer-to-peer, right? So the destination is actually here. Okay, because it's the destination is the router itself. That's why it goes for input. Okay. After that, it's checking, is there any IP security policy in that package? If yes, and then goes here. Okay. And then we do decryption. Okay. After the decryption, we coming into the pre-routing again. Okay. Okay. Perhaps I need to go back a few slides. As you can see this one, right? So when we receive a packet, okay, so what we receive is this, right? What about this one? This one is encrypted. Yeah, we cannot see it. So that's why when we receive IPsec packets, we have to decrypt it first, so that later on we can see uh, um, the IP address inside. Okay. Yeah, here. So we already decrypt. Okay. We already decrypt the IPsec packets, so we can see the original packet here. Okay. So we check the destination IP address. Checking again. Okay, number 7, we check the routing decision, so it 2 times. So that's why IPsec requires more processing. So that's why this kind of process requires support from hardware. Okay, especially for this process. Okay, CPU power. Okay, so we have checking routing decisions. Okay, and then okay, so actually it's not intended to the router itself. So we do forwarding, and then go to for post routing, checking IPsec security policy, no policy, and then goes here. So this one goes to this. Okay, so coming here. Okay, this one, when they go out, goes to here. Okay. Yeah, this is one example of, this is the previous one, the previous packet encryption and then decryption. Okay, this is the old style. Yeah, a few years ago, but I think to some extent still relevant, but they are writing in the different way. Okay, this is how the encryption looks like, and then this is the decryptions, And then IPsec on Mikrotik is available. It's 8:30 already. Oh, okay. So that time flies very fast, man. Okay, I need to finish this as soon as possible. Sorry, guys. Uh, well, wow, it's almost already 1 hour already. Yeah, so IPsec on Mikrotik. Mikrotik support IPsec. You can see IP and then IPsec here, right? Mikrotik support ISAC KMP, ISAC camp. Yeah, yeah, either IKE1 and then IKE2. Okay, so IKE1 has lots of complaint, not for Mikrotik but other vendors. So it is recommended if you use IKE2. Well, for the IKE2, perhaps we can discuss it in the later webinar. Okay, so when you have a IPsec with ISACamp, you have two sides. First is initiator and then responder. Initiator is define the policy, and then if it is recommended if you have a static IP for the peer, because as I said, you have two routers A and B. Okay, we talk about the side-to-side VPN. If the IP address here is keep changing, and then you will have problem with the IPsec. Okay, because why problem? Because the IPsec will authenticate the will authenticate the IP address. If the IP address change, and then when you receive it, and then package is lost. Okay, the it will reject uh, the IPsec. Okay, so that's why you need to have a static IP address. Okay, for peer. So this is one IP address here, another IP address here. Okay, has to be static. Okay, do not change. Well, my IP address is always changed. So what should I do? Well, you can set up L2TP first. Okay, so you set up L2TP from here to here, and then on top of that you put an IP address, and then that IP address has to be static, and then you after that you set up the IPsec. So here's the process. Okay, you set up L2TP, and then on top of L2TP you set up the IPsec. Okay, so the encryption requires CPU power. So that's why it's recommended if you use the hardware with accelerator, a security accelerator. Okay, so like RB1100 or CCR. CCR must have a hardware accelerator. All right. What's next? This is how you set up peers. Okay. Yeah. So this is you set up the address. Okay. The address, here's the port, and then here's the local address, and then here's the authentication method, as I said before, right? Yeah, this one, right? Pre-shared, public key encryption, or what? If it is easier, and then you can use pre-shared key, okay? And then you put a secret, yeah, for pre-shared key, and then here's the template group, and then here's the encryption algorithm, okay? Both party must be similar. And then here's the Diffie-Hellman group. And then if you check here, you generate policy or not. Okay. Here's the hash algorithm for integrity. Okay, so because hash and encryption is two different things. This is for integrity, and this one is for confidentiality. Yeah. So this is confidentiality. Yeah. Okay. Yeah, And then this is the Diffie-Hellman group for key exchange. Okay, so these are the algorithm. Okay, you can pick. So make sure that they support. Yeah. And then you set up the policy. Okay. So this is the So when you do IPsec policy, you have two tabs, general and then action. Okay. So here is general, from where to where. Okay. So it looks like in the like a routing table, like policy routing, right? Policy routing. Okay, so this again, I put this is router A, this is router B, okay, and this is the internet. Okay, so for example, this is 10.0.0, sorry. So this is 10.2.0/24, right? This is 10.1.0/24, right? So here is the destination here. Okay. Oh, sorry. That's the opposite. Okay. So here you set up a policy, put it here, and here's the source destination is here. Okay. So this is the security policy on router A. Okay. Okay. So this is how you set up policy. And then when you set up the policy and then you choose the action, you encrypt. This is the, again, this is the router A. Router A is the one that is doing the encryption because we want to send data from A to B, right? From here to here. See the arrow direction, right? So you do encrypt and then level is required. See, IPsec protocols. Either you can use ESP or AH. And then check, is it for tunnel or not? Okay. And then for SA, IP address, yeah, it can be from here to here. Okay, and then, yeah, so that was the example, the concept of how you configure the IPsec on Mikrotik. Okay, so basically that's how it works. Right, guys, so I'm sorry it's a little bit late here. Any word from admin? Any questions so far? Sorry, perhaps it's a little bit complicated. I'm really sorry for that. Yeah, thinking about security. In the beginning, I was thinking, oh, I took a class for security when I was doing my study. Okay, I took a security class, but I was thinking to do click here, click that, and then you do encryption. But it's not, guys. I have to create like encryption. I have to do lots of calculation, do some programming things with C and Java, and then you have to encrypt from here to there with this kind of algorithm. So yeah, if you are planning to do the same like me, taking an encryption class, and then yeah, just prepare for that. Okay, so I think that's all, guys. Any word from admin? Hello, admin. Go ahead.
Yes. I'm here. Thank you for sharing. More than 1 hour. That is good. So I
Yeah,
think
really sorry for
everybody
that, man.
got that point. No problem. Can you maybe stop sharing and then we can take a
Oh,
picture
pictures.
together?
Yes, sure.
Yes.
Hello, guys.
Yeah.
It's picture time. Okay, as usual. Okay, please open your camera.
Yes.
Okay, give your
There is
best
person
pictures.
from
Oh, I have to turn
Bulgaria,
on my camera as well.
Philippines,
Right. Yes, people from all around the world. Okay,
Indonesia.
thumbs up. Okay, I'll take a screenshot. 1, 2, 3.
Oh, there is
Yeah.
Mr. Bill Gates as well.
Oh, from America.
From Bogor,
Oh,
I
must
think.
be early morning there. 1, 2, 3. Second page. And then, oh, finish. Oh, 2 pages only. Okay, that's fine. No
Fine.
problem. Right, guys. Thank you very much again for your attention, for your attendance. Hopefully, this gives you enlightenment for how the IPsec looks like. Okay, it sounds boring. Okay, I'm really sorry for that. Too much theory here and that. But I think, I mean, in order to understand, in order to use IPsec properly, you need to understand how it works. Okay, otherwise you just get lost. You go to any tutorial in the internet, click here, click that, and then when you have a problem, you don't know how to solve. You don't know where the where the where the issue is. Okay, and then yeah, I mean that's mostly because of you don't know uh, the basic fundamentals of how IPsec works. Okay, guys, again, thank you very much. Really appreciate that. And then I will see you in the next session. Okay,
Next week,
have a good
Thursday.
day. Have a nice day. Have a good evening for everyone. Okay,
Yeah.
stay safe. Keep smiling.
Bye bye.
Bye.